If we started building a skyscraper straight up into the sky, could it ever reach space? That's the question. At first glance, it sounds simple. Just keep adding floors until one day the top pokes through the atmosphere. Done. But of course, things get weird very quickly. First, what does it even mean to reach space? The international standard for space is the Kármán line, about 100 kilometers above Earth's surface. If you want your skyscraper to qualify as the world's first space hotel, the top floor has to cross that line. So how tall is that? For comparison, the tallest building we've ever made, the Burj Khalifa, stands at 828 meters. That's impressive, but it's only about 1/800th of the way. So we'd need a skyscraper about 120 times taller than anything humans have ever built. No problem, right? Just keep stacking steel beams. Except steel doesn't like this plan. Even if we had unlimited material, the sheer weight of such a tower would crush its base. Think of it like stacking pancakes. At some point, the bottom pancakes don't hold up the pile, they just become pancake mush. That's what would happen to steel, concrete, or basically anything we've ever used. The materials would buckle under their own weight long before hitting orbit. Engineers call this compressive strength, and Earth's gravity is very good at breaking it. What if we cheated? Let's use some hypothetical supermaterial, maybe carbon nanotubes or graphene, which people love to hype up in science articles. On paper, these materials are thousands of times stronger than steel. If you could manufacture enough of them, spoiler, you can't, then maybe your building wouldn't collapse. But new problems appear. For example, wind. At a kilometer tall, skyscrapers already sway a few meters in storms. At 100 kilometers, your tower would whip around like a fishing pole in a hurricane. And if the upper floors poked into the stratosphere, the winds get faster, the air gets thinner, and the tower becomes an enormous flagpole that Earth's atmosphere is desperately trying to snap. Suppose we engineer around that with stabilizers, dampeners, and maybe some enormous guy wires stretching across continents. Now you have a skyscraper that requires an entire country's worth of space just for its cables. Congratulations, you've built the world's most impractical monument. But let's keep going. Say you do reach the Kármán line. The top floor technically counts as space, but you can't just open a window and float around. You'd need airlocks, oxygen supplies, radiation shielding, and some way to stop guests from boiling alive in vacuum. At this point, your skyscraper isn't a skyscraper anymore. It's a space elevator with a hotel lobby. Now, there's another issue. Earth is rotating. At the equator, the surface is moving at about 1,670 kilometers per hour. If you build straight up, the top of your skyscraper isn't just higher, it's moving faster in a wide circle. The higher you go, the more the building wants to bend outward. By the time you're hundreds of kilometers up, the centrifugal force tries to fling the upper part of the tower off into space like a medieval trebuchet. Of course, some people might say, who cares about practicality? We're already imagining impossible things, so let's crank it up. Instead of 100 kilometers, what if we built to geostationary orbit, 36,000 kilometers up? That's where satellites hover above the same point on Earth. Imagine the view from the penthouse suite. The elevator ride alone would take days. But now your skyscraper is so tall that it weighs more than Mount Everest, and its base would punch straight through the planet's crust like a nail through cardboard. So your building would collapse, and also congratulations, you've started Continental Drift 2.0. And yet, ironically, this idea isn't completely useless. The concept of a space elevator has been around for decades. Instead of stacking bricks, the idea is to anchor a cable at the equator, run it all the way to orbit, and balance it with a counterweight on the far end. That way, the whole thing stays taut, held by Earth's rotation. It's not a skyscraper, but it's close enough, and theoretically possible if we ever invent materials strong enough. So could a skyscraper reach space if it kept growing? The boring answer, no. Real buildings can't get anywhere close without collapsing, swaying, or just toppling over. But the fun answer, yes, if you redefine skyscraper into absurd megastructure that spans the entire planet, costs more than all world economies combined, and probably makes Earth itself uninhabitable in the process. Still, if humanity ever builds one, I call dibs on the top floor apartment.